the card down here. There you go. It should be okay there.
I know everyone's a little tired from the whole day, but we have our last presentation of the day. The presentation is going to be by Jacqueline Bilston. She is a software developer working in data engineering at Yelp and also a co-founder of the Calgary Software Crafters, which is a club dedicated to collaboration and sharing knowledge on how to make developers' life easier. That's going to be, I think I should join that. After almost 10 years in application engineering, she decided to switch up things and learn something new by working with data. She's also fascinated by unique problems presented in testing big data applications and is always happy to learn more about new approaches to testing them. I'll give the stage to Jacqueline. All right, thank you.
Hi, good afternoon. My name is Jacqueline Bilston. I'm a software developer at Yelp, and today I'm going to tell you the story of how I learned to efficiently test my ETL pipelines. These are my talk resources. Some people like to download them at the beginning of the talk. If you're the type of person that likes to wait until the end of a talk to learn if it was any good before you decide you want to download them, don't worry. This slide is at the end of the talk too. I do think that this talk is pretty good, and I have a lot of interesting stuff to share. So if you could hold your questions until the end, that'll help me make sure that I have enough time to get through everything. And now let's start our story. Our story starts with a bug. And this is not a real bug. This is a bug that I've invented so that I can share my code with you. But it is definitely based off of bugs that I have actually experienced at Yelp. Like all of the best bugs, it started on a Friday afternoon, just as I was about to leave work. A data scientist named Jenna came to me and said, the number of interactions in the pandemic recovery table doesn't look right. This was weird because the pandemic recovery table was being generated by a pipeline that was fully unit tested. We had 100% coverage, and all of our unit tests were passing. But Jenna is the type of data scientist that has a sixth sense for her data. So if she said there was something wrong, I thought, I better go and check it out. And I did. This is our pandemic recovery table. It's a table that we use to track the recovery of small businesses over the pandemic. We do that by tracking the number of interactions our users have with the different small businesses each day. That could be something like leaving a review about the business, checking in at your favorite concert, or leaving a tip about the best place to find parking. We count those and we add them up into this interaction count column. And that's where Jenna had noticed the issue. You see, the interaction count column, it wasn't wrong. Well, it was wrong. It was very wrong. But it wasn't wrong because we were adding things up incorrectly. It was actually wrong because our review count was wrong. And she didn't know why our review count was wrong, but she said that we'd better go check it out because this was important. I mean, she was right. We weren't the end users of this data. It was used by more than a dozen teams at Yelp. And something was wrong with it. I don't know if you've ever had to go to your end users and say, there's something wrong with this data set. We don't know what it is. We don't know when it's going to be fixed. But you can't use it right now because any predictions you make off of it are going to be wrong. That is not a pleasant conversation. And so the clock started ticking pretty fast. My team dove in to try and find the bug, but there was just one problem. This is a diagram one of my team members made of about half of the system of pipelines we maintain at Yelp. And we knew where the buggy data set was, but that buggy data set was being generated by a series of upstream jobs, all of which had automated tests that were passing. So we couldn't rely on our automated tests to help us find that bug. Searching through all of that code manually took us 5 days to find the bug. We were a team of 8. That's 8 developers for 5 days. Not only did it take us 5 days to find that bug, because our automated tests were passing, we couldn't trust them to tell us when we'd fixed it. So we had to manually set up and rerun the affected section of the pipeline each time we wanted to see if we'd actually fixed it, and that took 3 days. This was incredibly frustrating because the bug was a one-line fix. This is the Yelp app, and on this app, you have the option of checking in. When you do that, we increment the check-in count column in that table. You also have the option to leave a review. And when you do that, we increment the review count column in the table. Now, these buttons are so close together that our users were doing both actions at the same time, and that was not two separate interactions, that was one. So we decided that we wanted to count only mobile reviews that did not match any check-ins. We knew what we needed for this. We needed a left anti-join. This is a join that basically returns everything in the data set on the left that doesn't match anything in the data set on the right. Unfortunately, there is another type of join in pySpark. It's an inner join, and it's the default. This returns everything in the data set on the left that does match the data set on the right. And the difference between these two types of joins is that parameter. That was the parameter that we'd left out. It took us 5 days to find this bug, 3 days to fix it, and 7 days to run backfills for 2 months of bad data. This is a costly bug. It is not, cheap to fix. And it was frustrating because we'd had so many tests in place. They were all passing. Now, I don't know if you guys have a unit testing strategy where you work, but unit tests, they're not hard to write, but they are also not exactly trivial to write and maintain. And the reason we do that is so that we can exactly avoid this amount of rework, and our tests had failed us. I decided to take a closer look at our tests to see if I could understand what had gone wrong. We had 2 layers of tests in place. One I call data tests. These look at our data in production and make sure it conforms to a set of rules. The other set of tests are ones that I would have actually expected to catch the issue. These were our unit tests. Unit tests make sure that for the exact same input, your code will produce the exact same output. They catch all of the silly little mistakes that developers make, and they do it quickly. These were the tests that hadn't worked. Now, I was a bit stuck. I didn't know why they hadn't worked. I was frustrated. But thankfully, when I'm stuck, I actually have a wise, old developer I can ask for help. If Uncle Iro existed in real life for code, his name would be Jay Bazuzzi. Jay is a principal developer and agile technical coach at Tableau, and he is one of the smartest, kindest, and most caring people about building up his community that I know. I went to Jay and I said, Jay, we had 100% coverage. Our test should have caught this bug, and it didn't. And then it cost us like 3 weeks of work. What was wrong with our test? It covered everything. And Jay, being like Uncle Iro, answered my question with a question. What bug are you trying to catch? I said, Jay, we're trying to catch all of the bugs. That's the point of 100% coverage. What do you mean, what bug am I trying to catch? Jay still did not give me the answer. He told me to go away and think about it. So I did. This is an example of the type of test we wrote. This is a logic test or a unit test. It takes in a bunch of large JSON files, then converts those into data frames, passes those data frames into our transform function. That's what ETL stands for, is extracting data, transforming it into a format that works for you, and loading it. This is the test for our transform function of this section of the pipeline. That transform function will return a data frame that we pass into another function that converts it back to JSON and compares that to another large expected JSON output file. This is where the problem was. At the time that I wrote the test for this, that was the size of our JSON file. There was about 50 different rows coming out of it, each of them representing a test for a different behavior. Now, it was so big that the only way I could figure out if my behavior change had worked was by comparing, with a diff tool, the old values in that file against the new values that my code was generating. I could take a look at the specific case that I'd added and make sure that the values were updating properly. But there were about 50 other rows in that table that the JSON file represented. And I don't know about you, but I can get pretty lazy. I am not about to manually calculate the expected output for 50 other test cases. And so I kind of scanned them to make sure they looked okay. And then I did what any good lazy developer does. I uncommented the function at the bottom of the code here, which basically copies the output from the new expected JSON file into the actual expected JSON file. And I wrote the bug into our tests, so it was expecting the buggy behavior. I went back to Jay and I said, okay, Jay, I see what you mean. The test was big, it was covering everything, it was testing so much I couldn't tell what was important. But how do I make it smaller so that I can figure out and write tests for the more important behavior? And Jay answered my question with another question. Have you ever heard of a staff squeeze? I said no, and thankfully Jay was kind enough to explain it to me. A staff squeeze is a bug-finding technique using automated tests that Kent Beck wrote about in a 2008 blog post when he was working on JUnit. It was invented by David Saff, and as a side effect, it will actually take a very large non-specific test and reduce it down to a smaller test that asserts specifically on the behavior you care about. So I decided to try this out on my test. I started by duplicating that large test, because I don't want to lose the original large test. It's still covering a lot of important behavior I care about. And at this point, we'd actually fixed the bug, so it was hopefully testing all the right behavior still. But it was at least testing that my pipeline did exactly the same thing as it did before. And then I took a look at the duplicate test. First thing I like to do when I work with a new test is give it a better name than that, because the right thing is not very specific. As a reminder, the behavior that we want is any mobile review that doesn't match a check-in should count as a review, and any mobile review that does match a check-in should not count. We'll start with a test for that first behavior. So I'm going to name this test. Test will count mobile reviews without matching check-ins. Then I'm going to run the test to make sure that it's passing. This is an important step because you want to make sure that you're starting out in a green state before you make any changes. I want to draw your attention to this green little check mark in the corner. For the rest of this presentation, I'm going to be running a lot of tests. If the check mark is green, that means the test has passed. If it is a red X, that means that it's failed. Then I'm going to start by looking at the structure of this test. We have an arrange block that sets things up for us. We have the act block that runs the code we care about. And then we have an assert block that makes sure that for the exact same input, we're matching the exact same output. The assert is where we are going to start. First of all, I'm getting rid of that overwrite expected function. It's dangerous. And then I'm going to take a look at the comparison that I'm doing. I'm asserting against the entire output data frame from my transform function, and I'm comparing it to that expected JSON file. But the problem is that I don't really care about the entire actual data frame for the behavior that I care about. I only care that the business with a mobile review and no check-ins has one review coming out. So in order to make that assertion specific, I'm going to add an index to both of the JSONs there. And the problem is that entire object is still being compared. And the index is not very specific because if I add a new row, then things get reordered and my test fails. But I only care about the business ID and the number of reviews matching specific values for this specific behavior. And so in order to make it more specific, I'm actually not going to assert against a JSON file at all. I'm going to specify what I want those values to be. So I want the business with a mobile review no check-ins ID to have one review. This assertion is now so specific that the only way it fails is if the behavior that I care about, the behavior that I'm testing with this test, breaks. I like things to be easy to manipulate and easy to read when I work with them, so I'm going to extract those into a method called assert actual result has correct review count. And it is that assert method that I'm going to drop into the bottom of my test. With this very specific assert method, I can now start to squeeze the bottom, and we're going to take a look at that transform function next. I am running the entire transform function which means that I am testing every single line in this transform function. I don't care about every single line for this behavior. Not every single line affects this behavior. There's other lines that do other things. So what I'm going to do in order to figure out exactly which lines I need is I'm going to do something called an inline, and I'm going to copy the body of the transform function into my test. I'm going to start now by taking that assert statement and walking it up one line at a time. I'm going to run my test, and it failed. Now remember, this assert statement is so specific. The only way it fails is if the behavior that I care about has been impacted somehow. So I'm going to walk that assert statement back down below that method again. And I don't know how construct post-pandemic recovery data frame actually affects my code. So what I'm going to do, or actually affects that actual data frame, so what I'm going to do with that is I'm going to inline it as well. I can see right away that the actual data frame is being assigned the value of the pandemic recovery data frame. So I'm going to change my assert just a little bit, and I'm going to get rid of that assignment, and I'm going to start walking my assert up one line at a time. This time, when I run the test, it passes. So I know that the line below that assert is not valuable for the behavior that I care about. I'm going to delete it from my test. I'm going to walk my assert up one more line. Test passes. Okay, let's delete that not valuable behavior. And I'm going to keep going all the way until I find my next failure. This failure, I can see by looking at the error message, is because we are missing the num reviews key on the pandemic recovery table. And that line there was a join of the reviews data frame to the pandemic recovery data frame. If I look at the pandemic recovery data frame, of course it's missing num reviews. And if I look at the reviews data frame, we have the business ID and the num reviews. So I'm going to switch that assert statement so that I am now asserting on the reviews data frame. Walk that line up one more line, run my tests, and now they're passing. I'm going to delete the line below that, and I'm going to keep going again until I find my next failure, which is this one. This is the count reviews function that's below my test there. And if I inline that count reviews function, I see something really cool. This is the join that caused the bug. This is the farthest up that I can squeeze the bottom. So because I've found the bug now, and I know which function I care about at the bottom, I'm going to start, and I'm going to look at squeezing the top. Squeezing the top is probably more accurately called simplifying the top, because you're not squeezing it like you do the bottom, you're reducing the number of inputs to the absolute minimum that you need in order to test the behavior that you care about. I can see right away with my IDE that I'm not using the tips and business data frame anymore because I've gotten rid of all that behavior I don't care about. So I'm going to delete them. The next thing I'm going to look at actually is the rest of the act portion of my test. And a little bit of a weird thing here is that there's two function calls in there, both of which are calling our system under test. Usually when you write a unit test, you only want to be testing one function call at a time. But thankfully, I can fix this by remembering what we are testing. For a mobile review that doesn't match any check-ins, we want to count one review. So what I can do is I can take that check-in data frame, I can create an empty data frame, and I can basically assign my check-in data frame to be that empty data frame. That way there's no possible check-in that can match my mobile review. This check-in data frame is grayed out. It's no longer being used. I'm going to delete it. I can make this simpler. We don't care about browser reviews. We only care about mobile reviews. So I'm also going to replace the browser reviews data frame with the empty data frame. And then I'm even going to make it simpler by reducing the mobile reviews down to a single mobile review in that data frame. I'm going to assign that there, and that is my simpler test. That was a lot of work. And so one question I get when I make quality improvements was, well, was it worth it? And it's a hard question to answer because of the 0 to 1 phenomenon. This is a phenomenon that happens when you're doing something for the first time that makes it take almost exponentially longer than when you do it the second or the third time. It's because you're learning things and you're setting up infrastructure and you're setting up things that make it easier for you. But thankfully, we can test this out by looking at the second test we need in order to fully cover this behavior we care about. That is that one mobile review with one check-in counts as 0 reviews. And if we look at that, we can start by duplicating the simplified test that we wrote, make the name a little bit more specific, so now it's test mobile reviews count with check-ins. We're going to update our assert statement so that instead of expecting one output check-in, we're expecting none. And then when we run our tests, they fail, of course, because we haven't updated any of the inputs. If we go to the inputs, we'll change the review data to be matching on data, because this is the data that I want my check-in to match on now. And I'm going to now assign that matching on data to my check-in data frame. So now I have a check-in that matches my mobile review. Run my tests, and they pass. That was easier. I might make it sound like at Yelp right now, we have a ton of really, really tiny tests. And like it's a complete nightmare to work with. This is not the case. We still have that large integration test in place. But we do have a lot of tiny tests to test the behavior that we specifically very much care about. We are always learning new techniques for improving the testing of our data pipelines. And the staff squeeze is one of the things that we use for that. I should mention also that one of the questions I get a lot is, if you have hundreds of tiny tests, aren't you updating, 10 or 20 tests every time you change a behavior? And that's not actually the case. These tests are so specific that the only way they fail is one of two situations. Either you actually have a bug and you want them to fail because you want them to tell you that it's there, or you've changed the behavior. And you really should be updating your tests then. These tests have already saved developers on my team days of work because they are so specific that as soon as they fail, we know exactly where the issue is and we know exactly what the cause is likely to be. These are my talk resources. Again, I promised you they'd be at the end of the talk. They're going up into the top right corner there. I also wanted to say thank you to all of these amazing people who listened to me give this talk about 30 or 40 different times. And I'll open it up for questions if anybody has any. Yes.
Great presentation, but to be honest, I'm a bit confused.
Yeah.
We kind of started with more like wholesome integration tests and arrived to a pretty common paradigm of, we should probably be writing atomicized small unit tests that test only the behavior intended and that fail only change the behavior.
Yeah.
Or like you said, for the two reasons. So, and I also haven't seen this looks like a perfect place to plug like the mark parameterize.
Yeah.
And hypothesis perhaps for as tools to basically create many tests out of some simple tests. So I'm curious, what is the kind of the moral of the story? Does that mean before writing a huge integration test, write a small atomicized unit test, or what is it?
What you take away from it is like what's for you, but for me, what I learned from it was that smaller tests can accelerate and make you more powerful. I think our team so I TDD my code, but I think our team didn't know how to TDD before I joined. They had a very large test, and sometimes you wind up in environments with very large legacy tests because those larger tests are much easier just to add one row to than to write an entire new test for. The staff squeeze was a technique that taught me how to reduce down and find exactly which pieces of my code needed, I needed to test for the behavior I cared about. The other thing is, like, I don't know if anybody's heard of the testing pyramid. It's a theory that says like end-to-end tests are more costly to maintain and harder to write than, say, an integration or a unit test. And integration tests are harder to write than unit tests. I struggle with this concept because it's hard for me to figure out, well, okay, but I'm testing this tiny unit here. How do I know that all my pieces are interacting together? Like, where exactly do I place my test? And the SAF squeeze is something that I can do in my own brain as I'm writing a feature to say, okay, I need a test at the BDD level here. Then I'm going to write my inner loop test down here. And I'm going to get more specific as I progress down. I usually write a BDD test first and then skip it sort of like as a goal to make sure that I'm heading towards the right outcome that I prefer.
Mm-hmm. So I guess a simple moral is, even in big companies where there is a lot of legacy code, there's a chance that unit tests are missing, and here's the recipe how to create a useful unit test where you feel like it might be missing.
It is help, yeah. I mean, yes, I've had friends who work for like Google and for Apple, and they also have tech debt and large tests and tests that aren't very great. So the SAF squeeze is one thing that they would use for that, yeah. Yeah.
How often do you run in where your unit test, not talking a bug,
yeah,
but you've got it, it's working, it's getting expected results, you hand it off to the customer and it's going like, no, that's not, it's not actually doing, not necessarily what's expected, but it's presenting a result, but it's the incorrect result compared to what their actual expectations are?
So we're an internal team. So we don't have external customers. We do have lots of internal customers for our data. Usually what we do is a lot of collaboration if we have users outside of our team. And so we actually have access to the customer very, very easily. We can ping them or have a call with them. So the collaboration we do is usually very much at the beginning of a feature and throughout the development, but a lot of stuff at the beginning to make sure that we are building what they want.
So you have a good expectation of what the real world would be.
Yeah. Yeah, we do. We have very good representations of what the expected data are. We have access to production data. So we actually have a test that we run after we deploy to one of our services where we run real production data through it for a week or for a few days to make sure that it's working. Those crazy things that can only ever happen in production don't break our stuff. Oh, sorry, I'll go back. Yeah.
When you were going through that SAF squeeze process to convert your test, did you ever encounter any gremlins where the test was passing, but in reality there were one line that was not atomic enough, and it was creating false data but canceling itself? So you couldn't ignore that line because.
So you're saying like I would have a test that. So I'm just trying to figure out. There's a line in my code that is generating data and then undoing the data it generates?
Not undoing it, but what I mean is that there is a line that is, for example, because those lines are not simple statements. You are calling a function. There is a function, for example, that has side effects that is affecting both things that you are comparing, for example.
Yeah.
So when you're after that line, it passes. When you're before that line, it also passes, but that line is actually messing things up.
Yeah, I see what you mean. I wouldn't use the SAF squeeze in isolation there. If I was refactoring a test, or if I wanted to make sure that I had before I refactor anything, I try to make sure I have an isolated sort of safe environment to make those changes in. And I do that with a few different techniques for handling legacy code. I use a technique called a peel and slice quite often, which pulls out those side effects and allows me to insert either mocks or simulators depending on what the use case is. And then once I've done that, I can start to refactor the actual code of the system and then figure out how to deal with those integrations, because integrations are always fun and each one is always unique to deal with. But yeah. Yeah.
Sorry for another one, but just possibly a dumb question. So the first test, the original state, right, was not a simple unit test.
Yeah.
Did you guys store unit tests separately from this kind of bit more complicated test so you could check whether your 100% coverage actually includes a unit test for the function? Because you ended up essentially writing an atomic unit test for the function, right?
Yeah, I use PyCharm when I write my code, which has code coverage built in. So if I can basically specify which suite of tests I run. And so if I just run my unit tests, then it will come back with the code coverage numbers for those unit tests. Whereas if I come back with the integration test, I can just get the code coverage numbers for the integration tests as well if I want that.
Yeah, so how come you didn't catch it sooner just by looking at the list of unit tests and realizing that this function was missing?
It wasn't missing though.
Okay.
It wasn't missing, yeah. It was there. I had just been testing so much with that single test that I didn't realize the behavior I would copied over and approved was broken. Yeah. Does anybody else have a question? Or? Cool. Thank you.